Welcome to A-Level and AP Physics. In today's lesson, we will discuss important past paper question from May-June 2021 paper 4-1. This question is about medical imaging, one of the most challenging topic for many students at this level. In this video, I will explain you this question step by step and in detail so you can have clear understanding how to handle this type of problems in future. For part A, simply we need to state how in a modern X-ray tube, intensity of X-ray beam and its hardness are controlled. Control means that how we can increase the hardness or how we can decrease the hardness. That is also true for the intensity of X-ray, means how we can control the intensity of X-ray. It simply means that how we can increase the intensity or how we can decrease the intensity. This is what question is asking us. First of all, let's try to understand what is intensity. We need to understand these terms, what exactly it means by intensity. Intensity, when we talk about intensity of X-ray beam, it means we are talking about the amount of X-rays. So this is the first thing you need to understand. Intensity refers to amount of X-rays. Amount of X-rays, we can also understand, it depends on number of electrons. Number of electrons hitting the anode. Number of electrons we can write down hitting the anode per unit time. Hitting the anode per unit time. It simply means that here is our anode. You can see this one is the anode. So this is anode. How many electrons are hitting this one per unit time? If the number of electrons hitting this anode per unit time is greater, it means intensity is higher. If less number of electrons are hitting this anode per unit time, it means intensity is lower. So this is what is meant by intensity. What is benefit of intensity? If the intensity is higher, means the intensity of X-rays is higher of X-ray beam, it simply help to produce image quickly. We can form image of object quickly. So that is the benefit of higher intensity. Question is asking us how we can control this intensity. This intensity, as I mentioned here, is depending on the number of electrons, and the number of electrons, they are depending on this filament. If we heat up this filament more number of electrons will be emitted. In order to emit more number of electrons, we need to increase the filament potential difference across filament. So this is our filament. So here is the potential difference. We have to increase this potential difference. If we increase this potential difference, more number of electrons will be emitted. It means the intensity will be higher. So we can say intensity will be higher, and vice versa is also true. If we decrease this potential difference across filament, intensity will go down because less number of electrons will be emitted from this filament. So this is what you need to understand about intensity. Let's try to understand what is hardness. When we talk about the hardness of X-rays, so what exactly it means? When we are talking about the hardness of X-rays, it means we are talking about the penetration power of X-rays. Simply means that if they have higher penetration, it means the energy is greater, means the energy of photon is greater. And energy of photon, it depends on frequency of X-rays, or simply we can say the frequency of X-rays. If X-ray photon, they carry more energy, it means the frequency is higher. As we understand, energy of photon, this is equal to HF. Higher the frequency, higher the energy. If the energy is greater, it means the penetration power is greater, or we can say the hardness is greater. Now the question is that how we can give more energy to X-rays, means how we can produce more energetic X-rays photon, and that is depending on the acceleration of electrons emitted from the filament. If we apply higher voltage between cathode and anode, as you can see here, this is the potential difference between cathode and anode. If this potential difference is greater, then these electrons, they will gain higher kinetic energy, means the speed will be higher. If the speed will be higher, it also means that we have accelerated more, or we can simply say it depends on acceleration of electrons. Acceleration of electron, if we accelerate these electrons more between cathode and anode, it means electrons will gain more kinetic energy, and when they will hit this anode, they will produce higher energy X-ray photons. This is how you can write down your final answer. You can simply say that by varying potential difference across filament, means this potential difference, if you vary this one, you can control the intensity of X-rays. In order to control hardness, you need to mention that by varying accelerating potential difference, it means that the potential difference between cathode and anode, this potential difference, by increasing you can increase the hardness, by decreasing you can decrease the hardness, simply you can control. And here by increasing the potential difference across filament, you can increase the intensity, or by decreasing potential difference you can decrease the intensity. This is how you can control. But if you look at the marks, this is B mark, means this independent mark, so this must be seen in your answer, so you have to be careful, you have to mention this one. You can mention current, or you can say PD across filament. This mark is also B mark, this has to be in your answer. For part B, a model of a limb consists of soft tissue and bone. As illustrated in figure 11.1, this is figure 11.1. Soft tissue has a thickness of 9.0 centimeters and bone has a thickness of 3.0 centimeters. Data for the linear attenuation coefficient of X-rays in soft tissue and bone is given in table 11.1. For soft tissue, this is 0.92 per centimeters, and value of mu for bone is 2.9 per centimeters. As you can see here, the value of mu is greater. It means that the bones are very good at absorbing X-rays. So that is also a very important point you need to understand. For part B1, we need to calculate intensity IS through soft tissue only, but it has to be in terms of I naught. This is very straightforward question. It's simply asking you to use linear attenuation equation, means I is equal to I naught e to the power of minus mu x. Mu here is absorption coefficient and x is the thickness, so let me write down here. So this one is the thickness, this is the thickness. I naught, this is the incident intensity, so this is incident intensity. You need to understand what these symbols are telling you. So this is the incident intensity and this is the transmitted intensity. So this is transmitted intensity. Transmitted. It simply means that if you look at this given figure, in this case incident intensity, this is equal to I naught, and transmitted intensity, this is IS. Question is asking us to find IS in terms of I naught. We can rewrite our equation now, so it simply means transmitted intensity, this is IS, and incident intensity, this is I naught, e to the power of minus mu x, and the value of mu for soft tissue is given, that is 0.92. so simply we can plug in value of that, that is 0.92. We also need to plug in value of x, the thickness. A thickness is given, that is 9.0 centimeters, means only the thickness of soft tissue, that is 9.0 centimeters. So this is 9.0 centimeters, but in this case they have the same unit, so that is right. But if they have different units, you have to convert units as well. Now simply we need to solve this one for IS and we will get our final answer. If we solve this, our final answer will be 2.5 times 10 to negative 4 I naught, and this is our final answer, and this is transmitted intensity through soft tissue only. There are 2 marks for this question. Let me explain to you how these marks will be awarded. First mark is C mark. You will get C mark if you have written this equation. And the second mark is for the correct answer. If your answer is correct, you will get another mark. So there are 2 marks in total for this question. First mark is C. If your answer is even wrong, but you have written the equation, you will get 1 mark. But if you got the right answer, you will get these 2 marks. So this is how marks will be awarded for B1. For part B2, we need to calculate the transmitted intensity IC through soft tissue and bone. But our answer has to be in terms of I naught. Now if you look at this figure, we have incident intensity, that is I naught. First of all, this will pass through the soft tissue, then it will go through bone, then again it will pass through soft tissue. And this is the transmitted intensity what we need to calculate in terms of I naught. We can answer this question using different methods. We can use a simple method or we can use a complicated one. We will use simple method for this problem so you can understand well that method, and next time you can use by yourself to answer same type of problems. First of all, look at this diagram. You can see here the red part. This is representing the soft tissue. So this is the soft tissue. And the second part, this is representing bone. And the third one, this is representing soft tissue again. So this is soft tissue. So as you can see here, first of all, we have soft tissue, then is bone, then is soft tissue. So I have just drawn here to give you better picture of this question. Now we can combine these two together. I mean the soft tissue we have here and soft tissue we have here. We can combine these two. So you can see I have combined these two here. So this is the soft tissue. The thickness of this soft tissue, this is equal to 6.0 centimeters, and the thickness of bone, this is 3.0 centimeters. As you can see here, the total thickness is 9.0 centimeters and the thickness of the bone is 3.0 centimeters. So the thickness of soft tissue is 6.0 centimeters. It is also given to us the incident intensity is I naught. Now let's say the transmitted intensity after passing through the soft tissue is I1 and the transmitted intensity after passing through bone, that is IC, and this is what we need to find out. Now simply we need to use linear attenuation equation 2 times to calculate the value of IC. First of all, we will use attenuation equation for I naught and I1. So I naught is the incident intensity and I1 is the transmitted intensity. So simply we can write down I1 has to be equal to I naught times e to the power of mu x, negative mu x. I naught, we just need to write down I naught, but value of mu is given. For soft tissue, value of mu is given, that is 0.92. We can also use negative sign here. So 0.92. And the thickness of soft tissue is 6.0 centimeters. So this is value of I1. But again, now we need to use linear attenuation equation for this I1 and for IC. But now here, this is a little bit tricky one. IC now, this is the transmitted intensity. We can write down this one is transmitted intensity. So this is transmitted intensity. This is transmitted intensity. But incident intensity now, this is I1. So this is incident. So let me write down here. This one is the incident intensity. Now simply we need to use equation and we can find the answer. Now in this case, our transmitted intensity, this is IC. But incident intensity, that is I1. Again, it has to be multiplied with e to the power of negative mu x, but I1 is equal to this. So we have to replace I1 with I naught. I will just use bracket here, and this is e to the power of negative 0.92 times 6.0, and this is multiplied with e to the power of negative mu, and this mu is for the bone, that is 2.0 9, and the thickness of the bone is given, that is 3.0 centimeters. Now simply we need to solve this one and we can find the final answer, the value of IC. If we solve this, our final answer will be 6.7 times 10 to negative 7 I naught. That's all what we need to do. Very simple one. Simply you need to understand how to use this equation. Which intensity is the incident and which one is the transmitted. By reference to our answers in B, we need to suggest with a reason whether good contrast on an X-ray image would be obtained. For that purpose, we need to use our answers from part B. In part B, we have calculated value of IC. We have also calculated value of IS. First of all, let's try to look at the ratio between IS and IC. IS divided by IC. IS is 2.5 times 10 to negative 4 I naught, and IC is 6.5 times 10 to negative 7 I naught. So I naught we can cancel. So the approximate answer what we will get from here, so the ratio will be equal to about 1000. So it simply means that IS is about 1000 times greater than IC. Very high value of IS and very low value of IC are simply telling us if we place a photographic film at the back of this part of the body, the part behind, means the part of the photographic film behind the bone, it will stay white because less number of photons will reach this part, less number of photons, but the number of photons, X-ray photons reaching where is no bone will be very high number of X-ray photons. So this part will be black, this will be dark, and this part will be white, it will stay white. So this will be too dark, we can simply say the part behind the soft tissues will be too dark, and the part behind bone, it will be less dark. So we can say this will be less dark, or simply it will stay white. So that's the reason there will be very good contrast. So in this case we can say there will be very good contrast. Why? Because IS is much greater than IC, and that's our answer. We can write down here there will be good contrast, and then we need to explain why. So the explanation, the reason is that because IS is much greater than IC. This image is a great example of good contrast. Simply you can imagine that the part behind the bone, so this is the part behind the bone, so this is what we will see on the photographic film. We will see the white part, so this is the part behind the bone, so we will see the clear image of bone, but the part behind the soft tissues is this one, so this part will be too dark. So this is a great example of good contrast, means the background is too dark and the area behind the bone, that is white. So this is great example of good contrast, and this is what you will see on the photographic film.